Hey, I wanted to talk today about shifting functions, or what we call translating functions, right or left. So I wanted to show you some examples, some parent functions that have been translated either to the left or the right, and how we would do that mathematically. So I'm going to talk about a couple of pretty well-known parent functions. One equals y equals x squared, the other is y equals 1 over x. Then we have y equals the square root of x. Then we will use y equals the absolute value of x. So first we're going to start with our parabola. And what happens if we replace everything in our parabola that used to say x, we either replace it with an x plus a or an x minus a. And so theoretically, we're going to shift this parabola. So I'm going to start with the first parent function parabola, and that is going to be y equals x squared. Y equals x squared, great graph. If you plug in 0, you get out 0, but then every number you plug in, you're going to take the square of it. So that parabola is going to go over 1 and up 1, because 1 squared is 1, and it's also going to go over 2, but it's going to go up 4, because 2 squared is 4, and it's going to do the same thing on the other side if you plug in negative 1 and negative 2. It's going to go up 1, and then it's going to go up 4. So there's our basic parent function. Now what happens when I replace x with x minus 4? And so theoretically what's supposed to happen is this graph, which is called x minus 4 quantity squared, will give me a double root, and that same root will be at x equals 4. So a double root just means that you get a bounce. You get this bounce off the x-axis. We had a double root at x equals 0 when it was the parent graph, and now we should have a double root at x equals positive 4. And so this parabola really is just going to be shifted to the right only, and that's kind of the only thing that happens to it. Shifts to the right, and we're going to draw that parabola, same exact size. It hasn't been squished or pulled at all. It's just been shifted, or what we call translated to the right. It still goes over 1 and up 1. It goes over 2, and it goes up 4. And it does the same thing on the other side as well. And so that's our new parabola. And let's just talk a little bit about, in general, if we replace everything inside the parabola, every x inside the parabola, with an x plus a, this is going to move the whole graph to the left. And if we replace it with an x minus a, which we just did, it's going to move the whole parabola to the right. So now I wanted to talk a little bit about finding the roots. I told you that we had a root at 4, but how do we know we had a root at 4? And so one of the things to do in order to find roots is you're going to set the y value equal to 0 and then solve. So we'll square root both sides, go to plus or minus 0, we'll bring the 4 over to the other side, and there it is. There's the root, or what we have called an x-intercept in this case, because it crosses the x-axis at 4. It actually touches the x-axis at 4 in this case. And so there's our intercept. Now, we also are very interested in finding the y-intercepts as well. So we're going to do the same exact thing, except for instead of letting y be 0, we're going to go ahead and set x equal to 0. And you can do this in any form of the parabola that you want. And so we're going to go ahead and plug in 0, and we know that the parabola is going to cross the y-axis at positive 16. Okay? So we talked about a parabola, but what about some of the other functions? Like, what if we replaced all of the other functions that we talked about in the very beginning with x minus 4? Theoretically, by doing that, they should all shift to the right. So we're going to look at the original parent function of y equals 1 over x, and it's got asymptotes because x can't be 0 and y can't be 0. So it's got two asymptotes, a horizontal and a vertical one, and this is what we call a hyperbola. And so our hyperbola at 1 over x looks like this, and if we moved everything to the right 4, then also its asymptote should move to the right 4, and it does. And so its vertical asymptote, x cannot be 4, because if it is, then we'll get 1 over 0, and y cannot be 0 still, and we will get the same exact looking hyperbola, but just shifted over to the right. Okay, moving on. Here we see an y equals square root of x function. So there's our parent function, y equals square root of x. And what happens if we replace x with x minus 4? That should be, again, a move to the right 4 of that square root function. And then finally, our absolute value function. So y equals absolute value of x. Every x value that I plug in, whether it be positive or negative, will be changed to positive. And then if we move that, x minus 4, that's going to move to the right, and there's that second absolute value function. So, to recap, any function, if you replace the x inside of the function with either x minus a, that'll move the function to the right, translate it to the right, and if you replace it with an x plus a, that should translate the function to the left. Okay, so translating left or right, replacing all of the x's with either x plus or x minus a. Okay, and one last thing. Does this work with non-functions? And the answer is yes. So simply stated, first let's start with a circle, radius 3, that would be the square root of 9, and there's my circle centered at 0, 0. What if I wanted to move this circle to the right, right? What if I wanted to move this circle to the right, and same thing, if I wanted to move it to the right 4, I would look for every x value and I would replace the x value with x minus 4. So this shouldn't change anything about the radius, it shouldn't change anything about the y values, it should still be a circle, radius 3, but in this case, it's got a new center, and that center is going to be at 4, 0 instead of 0, 0. And there it is. There's my circle. Okay? Great.